Hey everyone, hope you had a good weekend. So today we are not learning anything new. This is going to be an extra practice assignment on the compound interest and continuous interest formula. If you feel like you get it, then you can just stop the video now and go on and do the odd problems. But I am going to review the even problems just in case you feel like you need a little bit of extra instruction. So everything is going to be built around these two formulas. If you need to pause and jot these down somewhere, go ahead. That's what I'm going to be using. So number 2, Kim invests $1,797 in a retirement account, interest rate of 8%, compounded 12 times per year. What will the account balance be after 13 years? This is our principal. This is our rate. The time is 12 years. Nope, that was wrong. The number of times it's compounded is 12 times per year. That's n. The time is 13 years. So A equals P 1 plus R over N to the NT. So that's 1797, 1 plus 0.08 over 12. I hope you're all remembering to change that to a decimal by moving it 2 places. And then the power is 12 times 13. These problems are great because assuming you know how to set up the formula, you just type stuff into the calculator. And you can type it in just as it looks. It's not the sort of thing where you have to type this step in and then write it down and then type in the next thing and then, you just type the whole thing in. So 12 times 13. And this works out to be $5,066.59. That 8 rounds up to a 9. And let's check number 2 on the answer key. There it is. Okay, number 4. Amanda invests $4,396 in a retirement account with a fixed interest rate of 5%, compounding 2 times per year. How long will it take for the account balance to reach $8,776.59? So this is the principal, the original investment. This is the rate, the number of times per year that it's compounded. How long will it take means that T is unknown, and this is the final amount. So when we set it up in the formula, 8776.59 is the left. 4396 parenthesis 1 plus 0.05 over 2 to the 2t power. This is what we need to solve. So if we want to isolate the variable, I can divide both sides by 4396 to cancel this out. Divide by 4396. 8776.59 divided by 4396. 1.9965. And then over here, I'm going to leave a space because I'm sure you recall that a logarithm is going to be turning up here in a second. But also, what's inside the parentheses, we can simplify that. 1 plus 0.05 over 2. 1.025. Okay, so hope those steps make sense. We set up the formula, divided the number that was being multiplied here, divided that over, and simplified inside the parentheses. Now, we need to cancel out this base so that we can isolate the power. You cancel out a base with a logarithm. The logarithm's base has to match the base you're canceling. And then you have to do that to the other side of the equal sign. So that cancels out. I get 2t over here. The other side of the equal sign. So function, miscellaneous, use the log a button. The base is 1.025, and this number is 1.9965. We can round that off to an even 28, I think. I mean, we can do 28.0001, but next when we divide by 2, we're going to get 14 years, so we'll call that, close enough, or 14 years. Remember back in the day where you had to always label your answers? So there we go. Let's check number 4. Make sure that's right. Number 4. 14 years. Brilliant. So there's that one. Number 6. Bill invests $4,973 in a savings account with a fixed annual rate of 8% compounded continuously. There's that key word, which tells us we're going to use, oops, I just about messed that up, use this formula, A equals PE to the RT. What will the account's balance be after 10 years? So here's our principal amount, here's our rate, here's our time. A equals 4973E to the 0.08 times 10 power. 4973. Alphabet button E, power button, parenthesis, 0.08 times 10. And we get $11,067 and, oops, looks like 62 cents. That's my dollar sign. Trust me, that's supposed to be a dollar sign. All right, so 11,000 and some change. Let's see if that's the right answer for number 6. Yep, 11,000 and some change. All right, number 8. Jasmine invests this much money. Of course, that's a principal in a savings account with a fixed interest rate of 4%. That's R. How long will it take? How long? Sounds like we're trying to find time in this problem for the account balance to reach 8,000, blah, blah, blah. That's our final amount. So 8,071.41 equals E to the point, nope, did that wrong. Wow, you can tell I took the weekend off from thinking. 6878 E to the 0.04 T power. Okay, let me just go backtrack for a second. There's my formula. Yeah, okay, I did set it up right after a little blunder. We're good. Okay, so to solve for this variable, the first thing I need to do is divide by 6878. 6878. Cancel that out. So 8,071.41 divided by 6,878. 1.1735. And remember, as you do these, 4 decimal places. Pretty important. Okay, so I did not leave enough room for my next step, which, as you know, to cancel out a base, you need a logarithm. The base E has its own special logarithm called the natural log. So you take the natural log of both sides of the equal sign. That's what cancels out the right-hand side, gives you 0.04t. On the left, we have a special shortcut button. It's the ln button, 1.1735. Okay, you know what? If we round that off, even if we go to 4 decimal places because of all of those 9s, it actually rounds off to 0.16. Divide both sides by 0.04. And what do we get? 0.16 divided by 0.04. T works out to equal 4 years. Let's scroll down to 8 and check it. Yep, there it is right there. Okay, so short and sweet, hopefully. This didn't take too long. Just do the evens. You know, they're set up to sort of match the odds. Just one more extra practice to make sure you get this before we move on to a different topic tomorrow. As always, let me know if you have questions through the comments or email me, and have a great day.